Thank you, Hendrik, and thank you also for yeah. Maybe you can first quickly show the program. Yeah, thanks for that. So first of all, a warm welcome also from my side here from Agit. As Hendrik said, we are the lead partner here in this ET2SMEs project. Yeah, we are quite satisfied about the reaction on this event today. We have, as you already may have heard, we have more than 80 registrations for this event, more than 2/3 of them businesses, exactly the target group we are going for here, all over the cross-border region. I would like, no, please stay to the program. I would like, first of all, to say special thanks to our speakers, to the two keynote speakers from CERN, Han Dols, and from Nikhef, Jan Visser. And as you see here from the program, we also invited 4 businesses here from the cross-border region to give a short pitch on their project ideas, on their ideas for cross-border cooperation. And as already mentioned, we will have time for networking after the speeches, after the presentations. But how this goes will be explained when we are at the end of this program. So to start now with my presentation, maybe you should go to the next slide. First of all, what I would like to do is to give you a brief overview on the targets, on the added values of ET2SMEs. First of all, looking at the Einstein Telescope, well, just some short information about it. We are talking about the establishment of the 3rd generation of a gravitational wave observatory. And this, of course, is a real outstanding European research infrastructure. Maybe you can click also the next bullets. Yeah, we are talking about an investment of more than 1.7 million at least. We have a lot of jobs directly and indirectly created by this new facility. And of course, there are only 2 regions left, 2 candidate locations left. And we here in this cross-border region, we have a very good chance that this huge facility will be landing here in our region. You see also the time path here. We are talking about a process of 10 to 15 years that is before us. We started in 2020 with the European Strategy Forum on Research Infrastructure, the application for this. Yeah, and you see that the site selection, just to mention this date, will be beginning of 2025. And you see the further steps. Even if this seems to be far away, especially the installation, the commissioning and the operation of this facility, it is rather important to do now the right steps, to do now the right activities. And going to the next slide, well, you should know that we already have here in this cross-border region activities of more than 45 million euro projects, activities that are already connected with the Einstein Telescope and that are related to support this establishment of this facility. Well, looking at ET2SMEs, our project more in detail, we want to inform and involve companies, and we want to do this right from the start, right from 2022 onwards. We would like to let them profit from this huge research facility. We want to foster cross-border collaboration, focusing on the ET relevant instruments, but also on the geology technologies, not only directing, not only targeting at the telescope itself, but also towards multiple adjected and neighboring application fields that are connected with these technologies. The next slide, please. What we want to offer via ET2SMEs project is a value chain for businesses, especially. You see here, it starts with mapping and it ends with sustaining on the right side. And what I want to do in my speech is to give you a very rough idea. What are the added values? What do we do? What do we offer you? The next slide. So if we start on the left with the mapping, when we talk about mapping, we mean mapping of technologies and we mean mapping of competencies. To start with the technologies, next slide please, is you can find on our website, I already mentioned the instruments, the Einstein Telescope instruments technologies on the one hand and the geology technologies on the other hand. You can find here these different technologies, and in this online catalog each technology is explained. You see here the bullets on that sheet. It's an example of cryogenics, and each sheet contains information starting from a short description of the technology, displaying the challenges we are facing here in the next years regarding the Einstein Telescope, but also giving ideas on economic opportunities, showing ongoing or future procurements that will be explained later, and giving you also the contacts in terms of technology, but also the contacts you may need in regard of business cooperation. So this is the ET Technology Online Catalog. And the other offer we provide is the so-called mapping tool you see here. This is a new online platform that we are developing here for the whole Dutch, Belgian, German cross-border region. A new online platform related to the businesses and the research around Einstein Telescope. And this mapping tool gives the actors in research and in business the opportunity to be displayed, to be shown, to become part of this new developing Einstein Telescope community here in this cross-border region. How does it look like? Next slide, please. So this is an example how each research or business entity is displayed. You can create your own profile. We already have more than 250 players here online, and you can see also the further information on our website. So everybody, every business, every research institution who is interested to become part of this mapping is invited to be there. The next slide, please. Now we come to this part of company visits, networking, and also the consortia building, especially the cross-border consortia building. Well, what is behind that? First of all, what we do within ET2SMEs, and we're doing this since March last year, the next slide please, is that we visit the companies, the relevant companies here in this cross-border region. You can see that our partners already visited around about 170 companies in one-to-one meetings in order to learn more about their technologies, more about their services related to Einstein Telescope technologies. You can see on the right side how this is divided all over the cross-border region. And you can see also how it is divided so far regarding the different technologies. So this is a very important step to talk with each other and really to learn what is here in this cross-border region. Next slide. What we also do is what we call the networking, the expansion of your personal network. What we do is that we are present on larger ET relevant events, like you see here the Precisi Burst in the Netherlands. So larger events in Belgium, in Germany, and in the Netherlands. So you can talk to us, you can directly get in contact there. But what we also do is that we offer own networking events, and we will come back to that later. The next slide. Very important is not only to provide you with networking opportunities, but also to foster cross-border cooperation, what we call consortia building. So that will also be an important or a crucial part of our today's event. If you have a project idea around Einstein Telescope technologies, that is where it starts from. Then the first step is that you provide us a 5-step approach, a certain short sheet where you can lay down your idea. And what we also provide is that we hear from the business developers of ET2SMEs that we provide you with the contacts to potential complementary partners in order to foster cooperation around your project idea. Next. So then we arrange the matchmaking. That means we are looking for suitable partners across borders, knowing that not all companies already know the right partners at the other side of the border, and that we really prepare also matchmaking meetings so that companies can get in contact with each other and really can see if and how they may collaborate across borders. And finally, if we have a project team, we are also offering support in terms of funding. Next. But that is a part that will be explained also in the next step. So that is more or less the offer of consortia building that we provide within the project. The next slide. So then it comes to the part of the innovation vouchers and the innovation projects. What is behind that? Next slide. Click please once more. So what we offer is a so-called voucher scheme. We provide grants up to 50,000 euro for cross-border innovation projects of companies and research institutions here in these cross-border regions. The minimum requirement is that there are 2 companies from the extended Euregio-Meuse-Rhine, the extended cross-border region here, working together across borders. And we are working with different calls for proposals. The second call for projects, and we will have more of them throughout 2022. The second call is open until the end of this month.
We have to take a look at the time, please.
Yeah, I will do so, Hendrik.
Thank you.
My last point is about sustaining. So what is also important that we are collaborating not only within ET2SMEs, but also in 2 other cross-border projects, which you can see here, the eTest and the ET Pathfinder project, and that we are organizing jointly an Einstein Telescope Industrial Advisory Board, meaning this is an entity we will build up continuously across this cross-border region with regular meetings for exchange and giving advice on Einstein Telescope relevant issues for the next years. And if you are interested, you may already take into account the next meeting, which will take place on the 29th of April. So that is more or less, you can see here our partnership all over the cross-border region. I will not go in detail due to the time now. Yeah, and finally, I would like to say thank you for your attention and yeah, hand over back to Hendrik.
Yes, who will hand over right forward to Michaël Vannes from the POM Limburg for the next presentation. Do you want to share your own presentation, Michaël?
No, this presentation will be okay.
Okay, so yeah.
Hello everybody, I'm Michaël Vannes from POM Limburg, and at POM Limburg we are the regional business developer for the Flanders side. So some of you may have encountered me in person, but other people who are still interested or want to know which business opportunities there are for their company in specific, please don't hesitate to contact me or one of my colleagues. Or contact information will be shared later on this presentation. So without further ado, so the topic of this keynote is innovation with the Einstein Telescope, with the emphasis on with, because we look a bit broader than just supplying for the Einstein Telescope. And we'll get into that in a moment. So at the moment, we have 3 projects running for the Einstein Telescope for a region of the Meuse-Rhine area. So the first one is the ET Pathfinder, which is a functional scale model where they will put all the components together and test them, how they work together. And it's situated in Maastricht in the Netherlands. A second project is the E-Test, where they will be testing components on a very high level, and it's situated in University of Liège. They will be also testing geology, if it's suitable for the Einstein Telescope, and what the environmental impact would be for this Einstein Telescope. The third project is also the project on which this keynote is hosted, and it's the ET2SMEs project, which will be focusing on international business development for the Einstein Telescope. And the goal of these 3 projects is, of course, the same. It's to improve organicity for our region and to prepare ourselves for the coming Einstein Telescope. Of course, when this Einstein Telescope will come to our region, this will give a lot of business opportunities, and it will be from 26 onwards. But also now, there are a lot of business opportunities around this Einstein Telescope in the year 2022 and 2023. And this is something where I want to dive a little bit deeper on, because we have 2 main business opportunities for companies. And the first is the procurement, so we can deliver products for the Einstein Telescope, and more specific for the 2 Einstein Telescope projects, ET Pathfinder and E-Test. Second opportunity is participating in one of our innovation programs, like Ralf already mentioned, and this will be in our ET2SMEs project. So the first, the procurement side, you can find all the public procurements on our website, etest-emr.eu. You will find them on the tab Industries, and more specific under the button Procurement and Tendering. And you will find a link towards the platform of the client that will be is responsible for this specific product. And you can also find a list of the upcoming tenders. So for instance, the tenders that will be published in the coming months will be listed here, and you can see which is the project that this product will be used for, what is the topic of this procurement, and who is the client that will be hosting this this product of this procurement. And I've heard that also Stefan Hilt, the responsible for the ET Pathfinder project, is here. So if you have any questions about the tenders, please ask him in the chat. So when you want to find some more information about these procurements, you can click on the link on the ET website, and will be redirected towards the platform of the specific university. And there you can find more information. You can also register for the standard, and you can download the specifications of the standard and also upload your bid. And when you win this bid, you can benefit from three parts, actually. You can also develop the business. You have this project that you can build, but you can also increase your visibility because you can show to the world that you can deliver this product up to Einstein Telescope standards. And this is, of course, a great image builder. The third benefit is, of course, you get insights, and when the Einstein Telescope will actually be built, you have some experience in delivering this product. The second opportunity is, of course, the innovations, and this will make you able to find new market opportunities. So you can develop an idea, you can develop a new technology, and this will lead to new business and new clients. And to be eligible for this innovation project with the vouchers, as Ralf already mentioned, you should be an SME situated in the larger Meuse-Rhine area, or in combination with the cross-border partnership with another SME or a larger enterprise or knowledge institution. And when you define this project idea, you will be eligible for a voucher up to 50,000 euros and 50% of the total project budget. So this will mean that if you have a project of 100,000 euros, you would be eligible for 50,000 euros of subsidy. To be eligible for this voucher, you should be situated in the region of the Meuse-Rhine, extended with the larger Meuse-Rhine area. So this consists of, for Belgium, Limburg, Leuven, Liège, Huy, Warem, for the Netherlands, Limburg and Zuidoost-Brabant, and for Germany, Aachen and the Eifel region. So, as I already mentioned, it's not the goal to develop a product specific for the Einstein Telescope, because when the Einstein Telescope does not come to our region, or you should not be selected as the supplier for this Einstein Telescope, this would be, of course, a waste of time and money. So the goal should always be to develop a product that has a larger market opportunity. Within this Einstein Telescope network, we really want to show that we have the companies with the relevant technologies and their willingness to innovate, so we can improve our bid towards the European Commission to say this is a region we are capable of hosting this Einstein Telescope, and this is where the voucher scheme fits in. Innovations can take form of two paths. One is to increase the performance of your current technology, improve your accuracy, improve your quality. And the second one could be to develop a new product that could have an ET-related technology.
You have 1 minute left.
And this will be challenged towards 3 criteria. And this will be the innovativeness of the technology, the market potential of the technology, and the ET relevancy of the technology. So this framework has already been elaborated. So you start your project idea, you submit your project idea to the committee, and the committee will assess if this is by this assessment criteria of innovation, market potential, high-tech character, relevancy to the Einstein Telescope. And if you are given a green light, you can start your realization of your project, and then the voucher will be paid out in a lump sum after deliverables are completed. So where can we help you is in helping define the project idea, finding project partners, setting the meetings to find your ideal partner, and helping you with applying for these vouchers. So please don't hesitate to contact one of your project partners in the region. Here are our contact information. So we hope to see you in person, hopefully at one of our upcoming physical events. And for now, I want to give the words to Han Dols of CERN.
Yes, that's absolutely right. Our next speaker about business opportunities in big science, our keynote, one of our keynotes today is Han Dols from CERN. And I think you can already start sharing your screen while I will continue talking. So Han Dols is heading the business development section at CERN in Switzerland, with responsibility for building industrial strategic partnerships and innovation alliances in the 23 CERN member states. And I think you can talk about the rest.
Thank you very much. So you guys can see my screen, I guess. So let me do a little introduction here. So first of all, thanks for the invitation. I really appreciate to have a bit of time to share with you our learnings at CERN. So indeed, I'm calling from CERN, close to the French region, and I care a lot about what you're trying to develop. First of all, I studied physics a long time ago, so my heart for big science is absolutely there. Second, at CERN, we have been doing exactly this. We have also been working on building an ecosystem. It's really beautiful to see how you're now trying to build this as well in the Dutch, German-Belgian region. And thirdly, I'm born in Sittard, so I know the region very well. I've worked for 20 years in the industry around that area, so I can really relate to what you're building, and I can only encourage you. What you're doing is to start already now to create this ecosystem. So what I hope to do the next, let's say, 18 minutes is to give you a bit of a flavor of what we have done at CERN and how industry is working with CERN to get most out of it. And of course, there is always the view of procurement. So, CERN buys stuff. If you do big science, you need to acquire materials, machines, assets, but also we accelerate innovation. So people associate CERN mostly with that we accelerate particles, which is true, but we also accelerate innovation, and we do that with industry. And I'll give you a bit of a flavor. So just looking back, so when CERN started, it's nice to say that it actually started also with help of a nice convention in Amsterdam. There was already this notion that, it would be nice to do something back for society. And doing something back for society, it has to go through industry, because CERN doesn't make products. We don't make cars. We don't make wind turbines. We don't make medical machines. We develop technology that can be used by industry to bring to society. So we always need industry to bring something to the market. So then what kind of technology are we talking about? So of course, there is this famous Large Hadron Collider, 100 meters under the ground at CERN, that you see here, which is filled with a lot of technology, ranging from strong magnets, superconductive systems, cryogenics to keep the whole ring at 1.9 Kelvin. There are a lot of detector technology in there, microelectronics, data acquisition systems. So it's really a vast amount of technology that we need to master in order to do our physics experiments. But it's not just hardware. So what you see here is a sort of a picture of a collision of particles. And these collisions are, let's say, measured with detectors that are, let's say, super photo cameras, the size of a cathedral. And that generates a lot of data. To be precise, about 25 terabytes per second. So we need to do something with that. We need to decide very quick what data do we keep, what do we throw away. We need to store it, manage it, analyze it, visualize it. So there is a very strong digital component and digital field of know-how as well associated with these experiments in big science. So the whole field of technology that we see today is really ranging from vacuum systems to superconductive magnets, to sensors, to robotics, to microelectronics. And we have in total about 12,000 people working at CERN, working with CERN on all these technologies. And that is not just people who have a physics background. That's also a lot of people who know how to, let's say, do very good welding with metal. So it's really from engineering to simulation, from physics theories to very pragmatic, roll up the sleeves activities to build these machines. So how do we then work with industry? Of course, we'll do procurement, but I'll leave that aside for now. I think also Jan Visser will talk about that later. But I give you a few flavors. First of all, it sometimes happens that a company is struggling with a challenge, that are working on a new product, and let's say they need some advice on how to integrate microelectronics. And for that reason, they ask CERN for sort of a second opinion. They try to find which other ideas could there be to solve their problems, which we can facilitate. Another example is that we sometimes work together with industry to collaborate in a field that is of mutual interest. Imagine that we work on robotics and we want to make robots that can do standalone operations because there is a dangerous environment. Maybe there is also an industry around there that also wants to work on robotics that can be used in the chemical industry, for example. So then we could have a mutual interest to work on robots with a certain autonomy, and we can do a collaborative project on that. Thirdly, sometimes we work with universities to address specific issues related to the Sustainable Development Goals, United Nations ambitions, where we see how can technology used for that. We also have laboratories at CERN, of course, that are open for industry. Imagine that you build a new piece of equipment and you want to test it in a strong magnetic field, or you want to see if it can withstand a very cold environment, or you want to test it in a radiation environment, then we have the facilities to do that for industry at CERN. The last two examples are maybe something you expected more. So of course, we also have licensing of technology that we have developed ourselves. So we do sometimes file patents, but we don't do that a lot. We only file patents if we think it can be of interest for industry. And then we can give a license of such a technology to industry. I'll give examples for that. And finally, we see more and more companies are interested to really have a person working at CERN on a project that is of interest to the industry, and that can then work from a CERN let's say office and directly interacting with CERN colleagues. So these are, let's say, the flavors of interaction that we see happening at CERN to help companies achieve their own innovation goals. So in order to make it a bit more concrete, I'm going to flash quickly through some examples. So first, I want to give you a few examples on innovation partnerships. So here is an example of a medical facility, a hospital that built a facility to treat patients with proton therapy. You might question, what has this to do with CERN? Well, literally the room next to this looks like this. And here you see basically sort of a mini CERN. You see an accelerator ring with magnets to accelerate particles that are then used to treat patients. Another example of a totally different nature is our collaboration with the Bundesdruckerei in Germany. You know, the Bundesdruckerei is a state-owned company that prints the euros and also develops technologies to protect your passports. And we work with the Bundesdruckerei to see what could be technologies for the future to make passports even more safe, to make passports more reliable. And that is a very interesting field and a good example of how experts and scientists at CERN can work on inspiring, let's say, companies on things that have nothing to do with high energy physics. Another example is with Volvo. We have a collaboration with Volvo around fast machine learning, because we both have a mutual interest. We want to analyze data as fast as possible and take a decision what to do with that data. And for CERN, this is important for physics experiments, but for automotive industry, it's important if you want to build the next generation of self-driving cars. Another example I'd like to give is something we have set up in the Netherlands. So we have, of course, at CERN, I always say we are very good in finding a needle in a haystack. We have a huge amount of data and we need to find very weak signals. So what you need for that is data analytics. You need to have capability to master large volume files. And if you think about it, if you think about a market, a stock market, a commodity market where you're trading a stock, there you also might find very weak signals. For example, if there are entities who are trying to fraud or who are trying to deregulate. So we are working here to use tools developed at CERN to find very weak signals in finance data. And actually, I can share with you a newspaper today, as you can see in the top left corner, this is Dinsdag 22 February, is actually published today a very nice article about this collaboration, which we do in the Netherlands with CERN technology, where also the University of Maastricht and Wageningen is involved. Now you might think, okay, this is all stories for big companies and huge institutes, but here I am, I don't have a company of 8 billion revenue. What is in there for me? Well, I can tell you at CERN, we also have a strong effort going on to work with startups or SME-sized companies. And also here, we see basically that there is a whole range of applications that have found their way into society. So we're talking here about CERN technology, which has been adopted by these companies in their own innovation and in their own products. And that's ranging from companies working in the field of sensors to cooling and to ventilation, RF technology, digital sciences. So again, some examples to just show you how surprising this range might be. There is a company called Inside Art who is using the CERN Medipix detector to understand what's happening under these layers of paint to help determine the, let's say, the history of a painting and to determine if a painting is real, so to speak. Another example is a startup, BAQ, who is using a CERN technology to measure a specific radon gas in the atmosphere, and I honestly I had not heard about it, but radon gas is the second biggest cause of lung cancer after smoking, and we needed this equipment because radon gas often is you can find it in tunnels and in low parts of constructions. So why not help a startup to use this technology in a much broader world beyond CERN? Another example I'd like to give is this beautiful picture that you see here. It's a picture of the owner, a picture of the wrist of the owner of a company who has a license on CERN technology to basically use our detectors to not only measure exactly where is a photon, but also the energy, and transform that energy into a color, kind of. So that helps you to make color X-ray. And this is a beautiful example of how CERN technology can be used by a company by obtaining a license on that technology in order to build a very innovative, I would almost say disruptive technology. A last example I'd like to give, also a bit more closer to the Dutch content here. That's a company called Amsterdam Scientific Instrument, who was already for years licensing the same technology and is selling products all over the world using this. So again, those were examples on hardware, but also on software. You see that we see that the CERN software that often is open source can be used by companies to build new products around. So this is a company called Tint, who is using software that has been developed at CERN to make sure that all this scientific data that we have, we can preserve it for a very long time. Because if you think about it, how do you really make sure that all that data and these scientific insights that we get, that they can still be read 100 years from now? How do you really preserve that in a digital format that will be usable in decades to come? And that technology is now also licensed to very famous libraries around the world, where a startup has, let's say, found the courage to bring this product to the market around that CERN technology. What I also want to share here is, and as said, I think that Jan Visser from Nikhef will talk maybe a little bit more about it, but there is nice opportunity for you to share what I've heard talking to some suppliers. So I'm responsible for business development at CERN in these 23 member states. So I'm not responsible for procurement, but still I have spoken to a few suppliers, and I have noticed that, of course, they are happy that they can sell products to CERN, that they can sell products to big science, but it's more interesting to realize that they often add to that they learn new things that they can also use in their own products. So I'll give you an example. This is a company This is a Greek company who is specialized in metal production. And when they started to supply to CERN, they really in the beginning were a bit struggling with how to really do exact, very precise 3D measurements. And we had to actually help them, and we teamed up to install high precision instruments to do 3D measurements of these metal components. And by this company embracing this know-how, they have been able to also use this in other products they made, and to also use this same, let's say, capability to advance products that had nothing to do with big science. And another example I have is of a company called Blue Chip in Germany. They are, I think, in the market for, as it says here, for around 30 years. And they, you might have heard about them, they do a lot in OEM for PCs and notebooks. And we had to find a way to, let's say, install the same Linux software there in a large range of computer entities, and to make sure they were all exactly the same. So we have been teaming up on how to install that, how to make that work. So you have a very high, let's say, reliability on a large area of servers that you install that have been installed in exactly the same way. And this experience also helped them to gain access to markets in universities, for example, and other institutes that needed a large amount of servers that had exactly the same profile. So also here an example of a company who could benefit from supplying to CERN, not just by the fact that you get money if you sell something, but by the sheer fact that you learn new things. And the last example here is a company in Poland, and you see here a quote from their business development manager that they have been supplying now for a couple of years to CERN. And we really have been challenging this company to find a sweet spot between the performance of some ICT solutions and their power consumption. And of course, that's not easy, because you also, from a CERN perspective, want to make sure that your cost of ownership is low. And we together figured out some new ways to do this, and the company format here is using this again in other products. So with these three examples, I hope to have illustrated to you that companies work with CERN to innovate their own products, and you can do that by getting a license, by doing a collaborative R&D agreement, but also with procurement, you still learn a lot. So I'd like to wrap up. So how much time do I still have? Then I can...
3 minutes.
Perfect. So first lesson learned, serendipity pays off. And I can really imagine that some of you are now participating in this event and are basically thinking, yeah, I don't know what to do with this Einstein Telescope. You know, what does it bring me? And probably nobody knows the answer yet, but I have seen from CERN that by getting early involved and by helping luck a little bit, by helping serendipity a little bit, that you might suddenly bump into somebody who's working on a technology that you might also need or use or could benefit from for your own product development. So this serendipity, this helping luck a little bit by teaming up early and by investing time to understand what's going on, really is the basis. Another thing, and also we should be transparent on this, CERN technology, and I would say in general, big science technology, that's not easy stuff. It's typically deep tech. You need experts on both sides that really understand what they're talking about. And if one side of the table has no clue what cryogenics is, and the other side of the table has been working on cryogenics for 25 years, then you have a challenge, right? So there is a lot to be learned, but you need really passionate experts on both sides. Also, I always recommend to start concrete as possible in small steps. Of course, we can say, let's work together with Einstein Telescope, or let's work together with CERN, and we're going to make better cars. Okay, but how do you concretely want to do that? What is then the first concrete step that you want to do that meets your business needs and has a connection to a technology that is around there? And I think this is also something that really was surprising to me. So I have been working in industry for 25 years. I worked at DSM, at Metrology, and some other companies in Limburg. typically in the innovation side, and I'm used to the drill that, you know, next quarter results, next year results. In CERN, since I'm working here now, the timelines are, we sometimes need to look even 20, 30 years ahead. So these big institutes and these big science ambitions, they have large timelines. So mind the gap in objectives and timelines. But the good thing is, by teaming up, I've seen many examples of surprising things happening that would in another way not have happened. And that's what I really hope to inspire you with a little bit. So I think my 3 minutes are over, so thanks for that.
Thank you very much. Yes, for the interesting talk. And now our next speaker is Jan Visser from Nikhef, and he talks about spin-offs in big science. Jan Visser is responsible for contacts at the Nikhef with industrial partners in the widest sense, from collaboration in research projects, joint grant proposals, up to providing services to companies. So I think now, Jan Visser, the stage is yours.
Thank you very much for the introduction. Thank you, Han, for providing a lot of overlap with my talk, but I think I will I'll put a different flavor to it. So I focused on so Han has been focusing more on how he sees things from CERN, from a big science institute, and I'm focusing more on my experiences both here at Nikhef and what I've seen happening in the Netherlands, mostly also related to CERN, is that is my strongest link with big science. Let me kick off. Let's see, let me make sure that my slides move. Yes, so first, what is big? I mean, we talk about big tunnels and so on. But just to put things into perspective, the ring at CERN, which I refer to, is 27 kilometers in circumference and sits 100 meters underground. And living in Amsterdam, just within the ring, for me, a logical comparison is the A10 around Amsterdam, which has a circumference of 25 kilometers. But then a bit, the tunnel at CERN is a bit smaller than the A10, but it sits on the ground. So for the Einstein Telescope, we're looking at a similar scope, 3 arms of 10 kilometers, but even deeper underground. I think the aim is to somewhere around 300 meters underground. So that's big. So that's the size, but also with these institutions come sizable budgets and substantial staff. At CERN, there's 2,500 people, and mostly the majority are actually engineers. And we'll see what happens when we come to the Einstein Telescope. Another couple of examples. How do we realize these big infrastructures? So we need to push the boundaries and go beyond the state-of-the-art technologies. On the top left, you see the extremely large telescope with a lot of Dutch involvement. It's the size of the Colosseum in Rome. Just launched, also with Dutch involvement, the James Webb's telescope, where the solar shield is the size of a tennis court. So these are huge infrastructures, and nobody envisioned 10 years ago, or maybe even shorter ago, that you could build those kind of things. So we're constantly pushing the boundaries of what we think is possible. An example for CERN, the LHCb detector is now being read out fully into a computer, and the technology with which to do that, when they decided they would do it, was 10 years ago not available. So they just projected the progress in technology and assumed that the technology would be developed and available at the time. And luckily that all worked out. So if you look at all these pictures, as Hans said, it's clear that we cannot do this without industry. All the equipment and everything that's being built, we can have a vision in our head that we can make it, maybe one day, but in the end, there's nothing would happen without industry on the scale that we require things to be built. In the collaboration with industry, we will challenge you. because together we will have to come up with, are not available yet, but we need to come up with them together. The picture you see here is an example of accelerator technology built in the co-development between VDL in the Netherlands and CERN. So VDL went to CERN actually and said, look, we have these capabilities. This is our core technology. And I want to stress that if you want to work in big science, you should focus only on your core competences. That's the only way you will be able to move forward. So they went to CERN and said, look, this is the field of our core competences. Do we have a shared challenge? Is there something that you would need in this field that does not exist, but that you see the dot on the horizon, you see that you might need or you want to achieve? And CERN said, yes, we have a dot on the horizon. And actually the picture is there, you see it. That was the dot on the horizon and was not possible to achieve at the time. So they went into a co-development project, and in the end it worked out. On both sides, knowledge was increased, and in the industry side, they increased their knowledge. They managed to improve existing products, were able to expand their product range, found new customers, and also by doing these cool projects managed to attract and keep key personnel. Because some companies I've spoken to say, look, if I want to make sure that my best people stay involved in a lot of run-of-the-mill projects, I need to occasionally throw them something which will make them think, whoa, man, I don't know how to do this. And this will keep them on board. And this will, in the end, strengthen my company and make sure that I can have a future and I'm not stuck in a lot of basic things. There's a number of things, a number of ways to work with industry. As Han said, you can do this co-development, there's outsourcing, and there's knowledge transfer, and I'll touch upon those briefly. But first, I wanna throw this to you. I've worked in industry and I've worked in science, just like Han, and we've seen both worlds, how different the clock speed is in these worlds, and how their different views on the same topic can be very different and complementary. So in the end, you need each other to in the end achieve the ultimate goal of the science, but also of a company to grow and to be, let's say, still survive basically. If as a company you do not improve your products, if you don't move with the times, I mean, look at Nokia. I mean, they missed out on the touchscreen developed at CERN to put it in their new range of phones, and they basically are non-existent in this domain anymore. So companies need to move forward. I think in industry or in the scientific world, we're good in building one. Industry is good in building 1,000. So we need the scientists to come up with a prototype, and we need the industry to actually make it something that can be made many times. And I think for looking at CERN and the examples I showed, but also for the Einstein Telescope, there are parts that are challenging, but we need more than one for such a big system. Science is more about performance often. Industry focuses on reliability. Does it work once? Yes, good, but I want to start this engine of the car, or I want to do this 1,000 times. So it's not only many pieces, but also more reliable. And looking at the specifications that sometimes scientists throw at industry, in the industrial partner might say, look, but you really need all these specifications in every direction. Not only do you really need it in X, Y, and Z. No, actually only the X is really the critical one. Okay, then why don't we make it perfect in that dimension, and we can loosen up and make it cheaper and more reliable by loosening the specifications in other dimensions. So that is how I think the collaboration with science and industry is really something that we need to move forward. So now I come to a couple of examples. Another huge project, LISA, a laser interferometer in space, where these devices are sitting millions of kilometers apart. And at Nikhef, we're working on the photon sensors, a new area of semiconductor devices that can actually be run with photonics. The company that produces them gives us a parameter space. And like I've seen in Medipix, we use all the little corners of the parameter space. And then the company finds out that if you use all the corners of the parameter space, the reliability drops. And you might run into some problems. So us scientists using all the parameter space they think is available, and our feedback to the company improves their process, meaning that they can also expand their product range and the reliability of the devices that they produce for others. And maybe in an autonomous driving car, where you want to make sure that the damn thing works all the time. Some co-development projects here for CAME3net, a cubic kilometer detector at the bottom of the Mediterranean. The pictures on the top were first 3D printed, a time-consuming and expensive process if you want to make thousands of them. So together with Windesheim, we actually went into a co-development project to see if you could do injection molding and still have the same result. It took a while, it took some money, but in the end, in the long run, it reduced the cost significantly in producing these parts. At the bottom, you see, at the bottom left, you see some lines going off in the distance. Putting optical fibers at 3 kilometers down in the sea produces so much pressure that light won't go through. So in collaboration with industry, we developed a oil-filled cable, which makes sure that the pressure is not completely given through to the fibers and make the whole thing work. And MCAP is a small company, but they are particularly a company that went into a project like this. So look, we're not in this for a big profit. We think it's a very cool thing to be able to be involved in. And even though not knowing where it might lead, they got involved. And in the end, it worked. And now they find out a few years down the line that this has impacted their other products. They have expanded their product range, found new clients, and they have become a more resilient company because of it. Outsourcing. Top right, you see a picture of a prototype of a new detector that's going to be installed in 2026 if all goes well. In the heart of the CERN, we collide in the heart of the Atlas detector, we collide particles, and basically you want to detect the particles that come out with the minimum interference of material. So you want everything to be very, very light, and hence you come up with carbon fiber. But making such a big structure well is something that's challenged Airborne. They make thousands of carbon fiber products, but not to the stuff that we ask them. So we challenge them, and they learn from it, and they're proud to have been able to produce the parts for us. And similarly with all wiring that is needed to connect these detector parts, we linked up with a company that actually makes these EEG helmets for use, where also you want to have a lot of precision in connecting them. So instead of thinking of CERN, as Han also said, like scientific, complicated, difficult, and maybe an organization to which you can sell something, really look at it as what are my technology needs, and look at big science as a technology provider. And then not only CERN, and in the future, hopefully in the Netherlands, the Einstein Telescope, but other big science organizations as well. An example, some examples I've been personally involved in. I worked at Analytical. I did the supply chain for these Medipix 2 devices in 2006, 2007. They had first contact with CERN in the early 2000s. It took them 7 years to make a product to market. But since then, they've been following the various families and newly developed families within the Medipix collaboration, and have been selling thousands of pieces at the time since then. And so they are a company that really benefited from getting involved with CERN, and especially the Medipix collaboration. And I think the Medipix collaboration also benefited immensely, because whereas the scientists usually have one device they test, and if it every now and then needs to be reset or does something funny, we're not that bothered. Analytical puts 10 or 20 devices and ran them 24/7 for weeks. And they found all the little bugs that we never were able to find with one device being run maybe a couple hours a day. So this has improved a number of stability issues that were there, but we never found because we were not running the system so long. So in that sense, the input of industry using our detectors has been very beneficial in developing the next generation of devices. So the way industry looks at certain things is really beneficial for science. Then 2 spin-offs from Nikhef, Amsterdam Scientific Instruments. I was a co-founder in 2011, been involved for a couple of years, but now the company's been grown into, I think, between 25 and 30 people, and doing really well. And InnoSize is actually a spin-off from experiment Virgo. The developments that were there needed to build very sensitive seismometers by Mark Baker, his thesis, as you see in the bottom left picture, has led him to start a company in 2013, and they've been growing. Actually, they're now 12 people, and they're now being involved in a project with ESA to see if their MEMS seismometers could play a role in laser or in communication in space, to see how devices move there. So from ground-based gravitational wave into space through this startup from Nikhef. So you see there's also links within big science. I think I'm just in time. So one of the things I do also link to Hans' group at CERN is to see how we can push technologies into existing business incubators in the Netherlands. And they're open to work with anybody. So if there's something from the Einstein Telescope developments, a cool technology, we could use also these business incubators to see whether they have teams that could look at different applications. And so in the bottom line, you see in focal and air scission, they've taken the structured laser beam developed at CERN and have moved into very different applications in printing or using lasers to mark materials instead of ink. Ink cooling is now taking CO2 cooling from CERN detectors to servers in data centers. And Fire Dynamo is taking a bio-based simulation program for cells, seeing if they can do something in the world of forest fires prevention. So briefly, the main thing is to build relationships. If you're interested in tenders or in innovation, both are fine, but talk to the people in big science, exchange information, focus on your core competences, look for shared challenges, and then you can benefit from complementary competences. And keep in regular contact to make sure you are interested. As Han said, the timelines are huge. CERN has plans up to 2092. Somewhere along the line, you might be of use. And if you keep pinging them every now and then, well, once your core competence comes into play, then you can benefit there. Briefly about procurement. It's a big part of my job related to CERN. CERN buys for $500 million every year. If you want to be involved, also there, build a relationship, register in the databases, and how to find your way. Yeah, link up with the industrial liaison officers like me. Find us because we are there to help you. We are there to help you. We play a fundamental role to link industry to big science in every aspect of the way. If you have questions, reach out to me for CERN and other big science projects, and for Einstein Telescope. And specifically, you can also reach out to me and my colleague, Ralf Meyer. And with this, I'm just over time. But I want to thank you for your attention, and I look forward to get in touch with you.
Yes, thank you very much for your presentation. And I think next in our agenda, we have 4 company pitches about innovation projects. I think Mabri Vision, Jörg Riedel is the first one. That's right. So feel free to activate your microphone.
Oh, yeah. I was muted. Okay, yeah. Thank you very much for the introduction. My name is Jörg Riedel. I'm here for Mabri Vision. Slide, please. Maybe a very short introduction who we are. By heart, we are a optical metrology company. We were founded in 2015. We are right now at 35 people working here. And we more or less focus on the metrology side. We build optical systems, optical sensors. We do have optics know-how. Our core sensors are interferometry sensors that we develop ourselves, but we also implement machine vision solutions and do the engineering like handling, database integration, ERP system integration, and the like, so that we deliver turnkey solutions to industry customers. Yeah, I think it's enough for Mabri Vision. Yeah, slide, please. So our project idea is, since we come from an optical metrology point, and we do develop interferometry sensors ourselves, we had the idea of improving on white light interferometry sensors. As you maybe know, there is technology called phase shifting interferometry, which can be a very high precise measurement technology for surface characterization, and for use in continuous surfaces. This can be used very well. The downside is that it has a very limited range of unambiguity, meaning that if you have steps in your surface that you want to measure that are larger than the quarter wavelength, which is roughly 120 nanometers, you can no longer identify how high this step is. And our idea is to increase this range. Slide, please. By the use of multiple wavelength, which is basically a synthetic wavelength approach. We want to combine two wavelengths, two light sources in the same setup, so that we get a beat frequency of these two wavelengths with the formula given here as a rough estimate, and extend this unambiguity range to roughly 3 microns by choice of blue and slightly green LEDs. The key challenge in this project will be to handle the amplified noise with this synthetic wavelength. We intend to use the fine image from one phase unwrapping and use the broad beat wavelength approach for the rough structure. And for this, we need to develop this evaluation algorithm and also the hardware for this. Slide, please. I was asked to state which part of the Einstein Telescope we want to address, and one of the key challenges is improve surface metrology, which this is a part of. Since we see some applications where there are microstructures on the surface that need to characterize very well for maybe remachining or for qualification, and these steps can be a problem with phase shifting interferometry if nanometer precision is needed. Slide, please. So what is innovative about this is that is an increase of the measurement range of the precisest optical measurement technology we have to date, the phase shifting interferometry, which is from a hardware standpoint not that much extra, still is relatively fast, and it has this PSI or phase shifting interferometry level of repeatability of 1 nanometer or less. Sometimes it's 0.1 nanometers that are being quoted, depends on the surface. Slide, please. And we did some preliminary tests. As you can see here, we have an interference pattern with a green LED on a mirror. There is a crack in the mirror so that you can see more structure. And the blue LED, and if you switch both LEDs on, you see this beat frequency in the pattern on the right, where you have stronger and less strong interference fringes on the surface. For our project, we will probably not use both light sources concurrently, but in sequence, but this is yet to be determined. Slide, please. So finally, to conclude this pitch, we are looking for a partner, and we have two possibilities. One would be the partner that supplies piezo stages or mechanical stages that can be used for the phase shifting and the relative movement of the PSI. Basically, someone who has experience with optical setups, with the nanometer precision of movement of optical components. And also we are looking for an application partner, because since we are an optical metrology company, we are very much technology driven, and we are still looking for applications for this, because we do have one application that we're not so sure if it's actually applicable, but if there is anyone out there who thinks this might solve a problem for them, we would love to get in touch and see if maybe we can benefit from each other. So that's, I think that concludes my pitch. Thank you very much for the opportunity to present this idea, and I'm very open for feedback.
Yes, thank you very much. First of all, we have all the 4 pitches, and then we have breakout sessions, so then you can go more into detail. So our next pitch is provided by Innovation Handling, Wilhelm van Schaik. Mr. van Schaik, you should please activate your... Yeah, now it works.
I open my microphone. Yeah, we are looking for a vibration-free environment. Our company is R&D oriented, and we are specialized in acoustic measuring techniques. Not acoustical like music or something like that, but we use solely transit time measurements. The temperature, the speed of sound is very important for measuring the temperature of the air and the velocity of the air. And with that, we have a special thing, and that's line measurements from loudspeaker to microphone, for instance, is a line measurement, and that's the basis of tomographic visualization, measuring and visualization of temperature and flow fields. The airspeed we can measure from loudspeaker to microphone, and they can be very small. And with that, we can produce a temperature and flow field. One of the properties of air is that it is invisible. You cannot see the temperature of it, and the density also not. But we can measure the flow and also the momentum. If there is flow, then you have also momentum on devices, and momentum of the gives vibrations, and that vibrations you don't want. For that, because we developed electronics so that we can measure less than 1 millimeter per second the airspeed up to high speed, but with that we can realize ventilation, acoustic controlled ventilation, because the speed of sound is very high. You can very fast react on changing situations. And the project idea is that we can, around very sensitive devices, create a zero speed field with a uniform temperature distribution, because we measure also the sound, not only the speed but also the temperature. The combination gives new possibilities. And the next sheet, perhaps, if that's possible. What's needed for the Einstein Telescope? The need is that an unstable climate around the equipment will be frozen. You don't have any unwanted vibrations of the devices, and we can realize that with controlled ventilation. What you cannot see and not feel is if you walking around a very sensitive device, it gives a disturbance, it gives pressure waves and wakes, and it gives a time-dependent momentum or vibrations. Zero flow will realize that no turbulence will occur and also no vibrations. It will be very interesting for most applications that will be tested in air before they are using it in vacuum. So if you can test it in an environment where no vibrations occur, then it will be also work very good in a vacuum, or even better, because you have you got rid of the vibrations in the natural environment. The acoustic technology is not only applicable in gases, but also in liquids, also in solids and in vacuum. In vacuum means that we measure for instance, in metal. We measure the temperature in metal in less than a millikelvin. And so you can also see measure deformation of 3D constructions. And yeah, that's one of the things what rather new, that the temperature resolution is much less than a millikelvin. Airspeed resolution is less than with all other systems. And a stable integral climate situation will be obtained and maintained. And because sound is very robust, in principle, less or no maintenance is needed. And it could be a very interesting principle to use, not only in air, but also in 3D constructions to measure what happens with the slightest temperature variations. Okay. What we need for realizing projects with it is companies with physical background, ICT knowledge, network things, and interfacing. And perhaps in laser interferometry, we have also possibilities for new approach of certain things. Okay, that's global my contribution.
Yes, thank you very much for the presentation. And I think we can go on to the next one. It's Amparam. It's Dr. Pierre-Olivier Santacreux.
Yes, thank you. I'm there. You hear me? It's okay?
Yes, we can hear you. And the stage, the screen is yours.
Okay, thanks. So next slide, please. So I will present Aperam experience in a big science project. I have a first slide to recall what we are. So next, please. So Aperam, it's a worldwide company, well positioned in stainless steel, specialty steel, and nickel alloys. We also produce electrical steel. So we are quite big. We produce about 2.5 million tons of steel. We are 10,000 people around the world. But our main productions and asset footprint is in Europe and Brazil, with our biggest melting shop is in Genk, and the second one is in Châtelet in Wallonie. So we are well positioned in Belgium. For sure, stainless steel and alloys are obtained from scrap and recycled at infinity. So when you build a new plant, it's good to know that you have a low content CO2 materials. About innovation, we are about 135 researchers, mainly located in France and in Brazil. We have a large portfolio of patents. And we were, in fact, very early in the adventure of physics. In the 19th centuries, we were associated with the discovery of the INVAR, which is a binary alloys of nickel and iron, with a very low thermal expansion anomaly. And we were associated with the Nobel Prize of Guillaume, Swiss physicians. And so we're still interested in all new development in physics, for sure, through metallurgy. Next slide. So I will start with our first big project in big science. So it was in 2000 with the Large Hadron Collider of CERN. For this project, we have developed two kinds of alloys. First one was a non-magnetic high manganese alloys for some part of the collider, the collar and the cold mass. So it's a structural part that are around the coils. So the specification is to have a very low permeability, magnetic permeability, around 1, and at cryogenic temperature. Also, we need to have thermal expansions for a thermal freezing of the copper coils. Why we designed the thermal expansion coefficient for this process. And this thermal expansion must be the same between room temperature and cryogenic temperature, 1.8 Kelvin. And last not least, we need high mechanical strength because to make light the system. The second alloy we have developed for the CERN was a liquid helium transportation pipe in INVAR. So I talked already about INVAR. These versions keep this very low thermal expansion. We could understand the interest of a low thermal expansion due to the thermal dilatation of the system and the liquid helium temperature. And with the M93, we get also a very high strength, so we can have a light and high strength tubes also. And now this kind of development help us to supply the market for liquid hydrogen transportation with this kind of alloys and others. So next, please. And so our other big science project since 2014. So we were first on the International Linear Collider, but you know that it's not yet financed. And for this project, we have developed a new alloy for the shielding of the superconducting radio frequency cavities. We named this alloys CryoPhy. We also developed this grade in US with a partner, and the alloy is known as A4K. So it is dedicated to high effectiveness magnetic shielding at cryogenic temperature. So we want, in fact, to reduce the influence of Earth magnetic field by reducing by hundreds. The grade must have a very high magnetic permeability, so it's the contrary of the previous examples, and also at cryogenic temperature. If you understand the permeability, it's about 70,000 in this case, so compared to 1 in the previous example. So Because the ELC is not yet launched, we first developed this grade for demonstrator, X-ray free electron laser. So there is a big project around this equipment through in Germany with the DESI, with Japan with the KUK, and with the CEA of French. So you can see these. We supply in fact these big tubes here to shield the radio frequency superconducting cavity made of nodules. So we get a free project for these alloys. So this is the free example I can show you. Next. So last but not least, our biggest experience in big physics was the Brussels Atomium, as you can see. We are ready to participate in any project. We have the experience to supply big tubes and for this kind of equipment. And if you want more information from Aperam, you can contact Patrick Toussaint, my colleague from Ghent in Belgium. So thank you very much.
Yes, thank you very much for the short pitch. And now, last not least, we have Professor Dr. Holger Heuermann from Heuermann HF Technik in Germany, I think.
Hello. Nice to come into my presentation. Please, can you go on with the next slide? I would like to talk about a new radar system, and our company is a spin-off company from the FH Aachen, the Applied University of Aachen, and here especially from my Institute of Microwave and Plasma Technology, IMP. And the company was founded 2008. The company HHF commodifies systems using two new base technologies of the IMP. One of the base technologies is a microwave plasma technology for sources, systems, and applications. In principle, similar to the laser technology, you can do already with this kind of plasmas a lot of applications. But we will talk today about the other base technology, what is also useful for a lot of application, and this is the so-called mixed frequency vector measurement technology. And microwave people talk about VNAs, vector network analyzers, that is really often used for this. And here I will talk now much more in detail about the harmonic radar system. That is one several proven application. I will say something about more of this and the new nonlinear network analyzer. We have made, and we can make a lot of other applications with the space technology. For instance, we have realized a hardware for the German Physical Technical Institute in Brunswick in form of a so-called vector PIM measurement place. And that is a reference measure, upcoming reference measure place for this national institute. That is the first hardware to perform in the future this kind of measurements. Please, can you go on the next slide? Now we will talk about our highly sensitive harmonic radar for Doppler and remote sensing measurements. Classical microwave radars are robust in challenging outdoor conditions and have become a valuable additional sensor for vibration monitoring and analysis in large distributed systems. You know, this kind of radars are meanwhile standard in cars around to the sides and to the fronts. And we have a lot of standard radar systems now in the world. In contrast to this normal radar system, a harmonic radar only measures reflections from cooperative radar targets, a so-called transponder, and we call it also TAGs. And this is therefore extremely robust against unwanted radar returns. We call this radar returns clutter, achieving a higher level of confidence in the distance results. This technology can be used to track the movement of survived reference points and surrounding of the ET. Please, can you go on? And now I'm coming to the ET relevant developed needs. Gravitational waves share the same frequency range as many natural and artificial seismic phenomena. Interference rejection in the interferometer is paramount for lowering the noise floor. It is accurate and reliable measurement is important to evaluate of detector events and adapted interference mitigation systems. Our harmonic radar technology allows to reliable remote monitoring of seismical survive points. Additionally, it can be additionally associated to the seismic sensor toolkit for monitoring otherwise hard to research areas inside the instrument's perimeter. And especially be joined where installing the required and sensor infrastructure and conductivity can be difficult. That is hard theory. I will show it much more better in the detail on the next slide. We are talking now about a robust and clutter-free radar. And we have performed measurement directly from our institute. Our institute is in this area of a floor. And we measured on we have a floor in it with a distance of 65 meters. And we measured indoor with this harmonic radar from one end to the other end to the TAGs. And we have installed a lot of additional reflectors so that we have not a normal light of sign. Normally, microwave measurements cannot work in this kind of floor without these reflectors. Right? Here you see the starting point where the harmonic radar is installed at this end of the floor. Is one building. It's connected with the other building with a blue bridge area. Here's the light of the bridge. Here we come from this point to the bridge area, and on the next slide with the detailed reflectors, you see 3 reflectors in 49 meters, and a ladder with also big microwave reflector and of a kind of a brittle triple mirror. And at the end of the floor, we have installed the TAG. You see the TAG on the right picture. It was in 62 meters distance to our radar system. And the TAGs consist of antenna with 2 antennas, one for the incoming frequency and the other one for the outgoing frequency. It is only installed 1 microwave diode. No energy, nothing else is on this TAG. It makes a harmonic. And that is the reason that we call it harmonic radar. And if you're looking in the on the left picture, upcoming picture, you see a peak, and this peak is in a distance of 62 meters. We can measure over this floor with 62 meters, and our measurement value is by minus 150 dBm, and that is in absolute values 1 attowatt. That is the most sensitive microwave sensor what is ever presented. We have already used it for a sea rescue system. It was possible to measure people in a distance of 6 kilometers in the water, and we have no clutter. You see no reflection from the big reflectors, because this radar is only sensitive to the tags, and we can install one tag at one side of the tunnel and the other tag at the other side on the tunnel, and it's no problem to measure over 10 kilometers with the system. Please, can you go on? And the next. Yes, we are also looking for a demand partner. The potential cross-border partner should have a detailed system knowledge about the Einstein Telescope to apply our technology at the right points. The application are high sensitive Doppler measurements to detect minute mentions and oscillations we are changing with of the microwave signal, and that is much more sensitive than a classical Doppler radar. And we have in this radar system no problems with other movement objects, only the tag is measured. And the second one is an accurate distance measurement, including transfer function measurement to the of the measurement distance and over time, and the control continuity in the radar radio channel. With the transfer function, we can control if something is changed in the channel, and and you can see it directly also that we have no fixed conditions. Also we can also measure in principle the influences of people or something moving or something is wet in the channel. Then we can see it also with this kind of radar system. Yes, and I guess that was the last slide, and I'm open to answer your questions. Thank you for your attention.
Yes, thank you very much for your pitch.